Well, thank you everyone for joining me here today. My name is Lisa Ann de Garcia, and I'm just so happy that you are here because we're going to talk about something that is really important, and that is the 6 developmental math levels. And those are important to know if you are working or trying to reach a struggling math learner in your life. So what I want you to do is to take a moment, pause this video, grab a pencil and a piece of paper, because the information that you're going to receive is going to really help you know how to identify some trouble areas in your child and how to move them to the next step. So go ahead, pause, and get that pencil and paper. So is this you? Are you by any chance a teacher who has had students at many different levels in your mathematics class? Or perhaps you're a parent, a homeschool parent, or a teacher who has a student that's obviously struggling, but you just don't know how to reach him other than teaching the same concept the same way over and over again, just hoping that he'll finally get it. Or do you just feel that your child just doesn't have any sense of numbers? I used to feel the same way. When I was in the classroom, I was a classroom teacher. I was working with students of multiple levels in my class. I used to teach inner city schools. And I was, by this time I was an upper grade teacher, and I was unaware of what the developmental processes children needed to go through in order to be successful in the upper grades. And that's something I really wanted to know. Even though I started my career teaching in the primary grades, I wasn't taught in college myself back then what were the developmental processes. I just kind of taught math and just hoped that they would get it, basically. So by the time I was teaching upper grade, I was really trying to figure out, okay, what really are these developmental processes? Because I could see that many of my children were definitely not where they should be. I also felt that I wasn't reaching my most struggling students in the way that I would like. So as a math coach, when I left the classroom, I started coaching, and that's when I started really studying children in all grades. I finally had access to kinder through 6th grade. I was testing them, and I was looking for patterns. And then I studied also simultaneously all the current mathematical education research that I could find, and learned how to apply it to the classroom. And I had, again, from kindergarten through 6th grade, and I was able to apply different research to different settings. I eventually went to the university, and I was offered or invited to co-author a math methods textbook for new teachers in the math methods program. And that even made me study more, because now I had to articulate everything in writing, all the facets of elementary mathematics, because our book was all about content and all about pedagogy from basically preschool to 8th grade. At this time, I was then able to instruct new teachers how to apply everything that I had to learn into their classroom environment. I was able to be a part of a professional development committee where we were professors and school leaders from 5 local districts. We worked under an NSF grant for a school-wide professional development grant. And what we were doing is we were working to take schools, the entire school, and move them. How do we move them mathematically? At home, about this time, my middle child was in 5th grade. He has autism and a severe language delay, so he can't really access the curriculum in a regular setting. So he's always been in a special day, special kind of setting because of his language. So I decided to try to apply everything that I had been preaching to my students in testing, how am I going to teach him division? So I really believed by this point that all children learned in a similar way. but I wanted to prove it with my son, who I was figuring, how am I going to teach this kid division? It's so language intensive. How am I going to make him understand? And so I wrote up my experience in an action research project, and I even created a website that described this process. I then had a very special opportunity that was very dear to me. At this time, I was asked to kind of volunteer co-taught a mathematics course in the special education department. And it was based on all the principles that I learned from just learned up to that point and through teaching my son. So I wanted to share with teachers who were going to be teaching in the special ed community these same principles. So moving on, after that, I moved on to my dream job, which, if you can believe it, my dream job was working in schools with struggling math learners, because I wanted to go back into the trenches and figure out how to take all this theory and everything that I learned, and I wanted to try it on myself. So after trying to figure out how to make what I know fit into some kind of a program, because it's a lot of information and you're working with children for very small periods of time, I needed a way to kind of, how am I going to collect and keep track of data? Because at the end of the day, if I go to, my principal is going to ask me, well, how do you know that they're doing better? So I needed some way to try to figure out, how am I going to collect data? So it led me to create this developmental test, which is, it's observational, so there's a lot of note-taking. And after grappling with this for a while, I figured out a way to quantify it so I could easily see numerically student growth throughout the year. So today I'm going to describe what these developmental phases are. I did not invent the phases. They actually came out of the First Steps work from Australia, and give you a brief description of each one. So then it's just in hopes that this will give you a better mental structure for to understand where your struggling student is and how he's performing to his same age peers. And so I'm going to list them quickly here, and then I'm going to list them individually and provide some examples and go into a little bit more detail. So this first phase, which would be around the preschool time, is the emergent phase. It's the very first phase that develops. Then when they're about kindergarten, they're working in the matching phase. Now in kindergarten, they might be working in this phase. It doesn't mean that your child is in this phase, but that's the kindergarten work, is basically around the matching phase. And then they start to get into the quantifying phase, and first grade is mostly dealing with this quantifying phase. And then we have what we call the partitioning phase. That's mostly second grade type work. And the factoring phase covers about third and fourth grade, and the operating phase about fifth and sixth grade. So the emergent phase. In the emergent phase, so here's a few bullet points that children know that numbers signifying quantity, that it's, and down here, that they are different, that numerals are different than letters, that it means an amount. They're able to rote count to about 10. Some kids can rote count more, but it's just rote counting. They can identify about 1 through 5 objects by sight. That's actually called subitizing, a mathematical word. And they know more and less and the same. They're starting to know that they have more of something or there's less, but they can't tell you how much more. Just they know that it's bigger and smaller. So the big takeaway from this stage is that children rote count, but they don't understand yet quantity. So it's okay to let them rote count even up to 100. They need to learn the names of the numbers so later they can deal with learning the quantities. When they get into the matching phase, some of the big takeaways are that they're able to rote count to double digits. There's one-to-one correspondence. They can count accurately. So there's different types of counting. Some kids have to move, some kids can just touch them, and then the higher stage would be to use their eyes. Depending on the quantity will depend on which strategies. If somebody gave you 1,000 pennies, you will be moving each penny to make sure that you are keeping track. But if they put 5 pennies in front of you, you can just count with your eyes or even sabotage those. In matching, when there's word problems, they are directly modeling them with objects or acting it out. So word problems, they're pretty much solving through directly modeling the problem. And they are figuring out how many more or less to make the same amount. And they're able to relate one number to another. So in this phase, the big takeaway is children need to count lots and they need to count within their number range. A lot of objects within their range. Not too easy. Well, easy is okay, but not and not too hard. Just within the range, just to tighten a little bit more. Then you will see they'll start to develop a sense of quantity when working within the number range that's comfortable for them. So, you might want to try giving right now, if this is the stage where your child is at, maybe your child's around kindergarten or early first grade, provide them with 3 different sets of counters, 7, 12, and 23. Or if they're a little bit older, maybe a little bit larger groups, and see the differences in the way that they count. And how does providing a different set of numbers change and affect the way that they count? Then we move on to the quantifying phase in about first grade. So this is where children are starting to count on and count back. They're starting to do skip counting. You may see some skip counting in kindergarten. There's some overlaps between the grade levels, but in kindergarten, they're starting to phase out of the matching phase and phase into the quantifying phase. So they're developing a sense of quantity. They're combining using relationships. They're starting to develop this conservation of number, which might not completely take place until 2nd grade. And they're using concrete materials to model tens and ones. So a common misconception in this phase is when children are learning to count on or count back using a number line or a hundreds chart, they might start with the number they have. So for example, if you have 8 minus 3 and they start with the 8 and they need to take away 3, they start counting the 3 on the 8 and not on the 7. So they'll go 1, 2, 3, and then they get 6. So they're always 1 off. So whenever your students are using, or your child is using a 100 chart or a number line, and you notice that they're always kind of 1 off, that's why, because they're having trouble. They haven't really figured out how to count on and back. So I'm going to give you a little trick. So if you count, take a number line or a 100 chart, and then have them put the 8 like 8 little cubes or pennies or whatever on the numbers, on each number. And then when they remove them back, then when they remove 3, when they move the first one, they'll see that there's actually 7 left. So they remove 1 and they have to say 7 because that's how many are left. And then they remove 2, they say 6. And so you're kind of building this understanding of a number line through kind of a concrete, how are you bridging this, their concrete understanding to this abstract representation, which is a number line. So when they're around 2nd grade into 1st and 2nd grade, they're really starting to deal with partitioning, counting by 10 starting with any number. So if you ask the students, and I've seen even kids in 3rd grade, sometimes there's some parts of this that they never really click for them. But if you're on 4 and you ask them to count by 10 starting with 4, that's 4, 14, 24, 34. But they think if you ask them what are you counting by, they'll say you're counting by 4. So they still you have to give them some experiences to understand, well, what does it really mean to count by 10, not just to say the tens. Then they understand and use inverse operations for addition and subtraction. They are starting to develop place value for any 2-digit number, and they're starting to regroup when adding and subtracting. Partitioning phase is hugely defined by regrouping. Addition and subtraction with regrouping, tens and ones, 2-digit numbers, even, they're starting to multiply through repeated addition. So it's just the concept of adding over and over and over again, not necessarily, and with groups, they're multiplying because it's they know that there's, two groups of 5, so they have 2 piles of 5, and they're saying 5 plus 5 is 10 type of thing. And they're starting to develop a sense of fractions, and so they're starting to believe that equal halves can look different and compare basic fraction pieces. Now, what I have seen is kids do just fine with the number part, but in fractions, if they don't have enough experiences, they don't just, you don't just necessarily develop this, by itself, even though it's developmental, it doesn't come to them magically. So they have to have some good experiences. They can understand about equal halves looking differently in 2nd grade, but I've noticed that usually in 3rd grade we have to have some really good experiences with that because they didn't have so much exposure in 2nd grade. So that's the partitioning phase. A hallmark of this phase, this is the phase where most older students are stuck if they are struggling in mathematics. So if you have a 5th grader who just doesn't understand long division, doesn't get multi-digit multiplication, they're really stuck in this phase because they don't understand how the base 10 system works, and thus they're attempting harder problems such as multiplication. Later on, they're just learning procedures without reasoning or understanding what is happening. All the little numbers that are carried or brought down or whatever, they don't have any meaning, and so they can easily make mistakes, and they can't reason why their answers, if their answers even make sense. So they get some real off-the-wall answer, and that is obviously impossible, and it's okay with them because they just haven't developed that sense of number because they don't really understand how our number system works. Then we move into the factoring phase. So the factoring phase is usually around, it's the 3rd and 4th grade. In the 3rd grade, it's usually kind of easier multiplication. In 4th grade, the numbers get larger. So the factoring phase usually covers 3rd and 4th grade. In the 3rd grade, the numbers are a lot easier. They're just starting to multiply, and then it gets into the multi-digit multiplication and division in the 4th grade. The highlights of the factoring phase is that students, they know place value for 3-digit and larger numbers. So the numbers are getting larger in the addition and subtraction. They're starting to use arrays to represent multiplication, different than the grouping. And they're able to use different models for division because division, there's kind of a couple different models that match division. They're also able to use the commutative property for multiplication. So they understand that 4 times 6 is the same as 6 times 4, and they don't have to memorize both of them separately, but it's really the same problem. They are able to use other language for multiplication and division. And they're in the fraction side, they're able to represent fractions with models and pictures, and they can compare like and unlike denominators. So comparing unlike and like denominators is more in the 4th grade. But this is kind of the fractional understanding in this phase. So in this big takeaway from this is when they're learning arrays, this is really a huge problem actually. When they're coming from the partitioning phase and they're using those multiple groups, when they're learning arrays are when they have rows and columns, and especially if they're using the little square tiles, if they really push up those rows and columns together and to make an area model, they lose the groups. They don't know where the groups are because it's all put together. So the biggest advice I would give you is have them start off with making groups. then have them put those groups into columns or rows, and then have them stack those rows near but not touching, kind of near on top of each other, so one row on top of the other, or the columns next to each other, so they can see that their columns are come from their groups, and then either slowly or over time have those groups push closer and closer together, or if you're using squares, then have them touching, but then keep asking them, okay, where is the 6 and where is the 4 in this, just to make sure that they can still see where it is. Because if you just have them build it like one giant rectangle, they won't find the groups. Then we get to the operating phase, which is about 5th and 6th grade type work. Basically, students are now working in decimals, and they're operating with decimals and fractions. So they're counting by tenths, hundredths, and thousandths over the whole. They're using understanding of relationships to order decimals. They're understanding that when you multiply by a factor less than 1, the product is smaller, which is a huge, this one throws them off because they always have learned or thought they learned that multiplication, the product, would be bigger than the factors. So now all of a sudden it's smaller. And they represent fractions and decimals on the number line. And they write equations for multiplication and division of whole numbers, fractions, and decimals. So a big piece of advice for the operating phase is when you're introducing an operation with fractions or decimals, you need to first take it back to whole numbers so students can study what's really happening before going back to fractions or decimals. So a big example of this is 1/2 times 2/3. We might just simply multiply across the top and the bottom, and we might get 2/6, and then we would reduce that down. But if you ask the student to build it, or to, let's say, I had one student where I had to take an empty cup of water, I marked it, or I had her mark actually the thirds, had her fill it up 2/3 of the way, then I said go dump out half of it, and then, or they can do that and drew a picture and do the same thing. They draw thirds, and then they color in 2/3, and then they cross off one of the 2/3, which is half, and so what you left with is 1/3. So that is creating meaning of the problem. And but so first, if they have gone back to the problem and understanding, that multiplication means groups of, and then when they go to division and they build it, then they're making sense of the operation. And in this case, with the 1/2 times 2/3, then the students are like, oh, well, that's just taking like 2/3 and dividing it by 2. And now all of a sudden they're building this understanding of inverse operations versus and how it relates to multiplication of a fraction. So we have division of a whole number and multiplication of a fraction. And in school, we typically just tell them, invert and multiply. Doesn't make any sense. They don't know why. Teachers don't know why. But if we just make them build it, then they can make some of that meaning for themselves. So, how do we move students from one phase to the next? First of all, it takes time. These are developmental levels. And some students, they are able to move through phases faster than others. We have some kindergartners, working in a quantitative, almost a partitioning phase, and we have some second graders working in a matching phase. So they also need lots of rich experiences in the phase that they're in. So if they're really struggling, they need specific rich experiences in the phase that they're working in. And we need to provide experiences that are just a little harder than where they currently are. So that zone of proximal development that, Vygotsky would always talk about, wherever they are, just add just a little bit harder, and that will help them, move from to the next level. Now, if they're in, let's say, a matching phase and they're dealing with numbers of 5, we're trying to move them up to numbers around, between 8 and 12, for example, and then we're moving them, so we're not necessarily moving them out of the phase, we're just moving them higher in a higher level within that same phase. If you're a classroom teacher, Allow access to classroom material by teaching through context, which gives multi-entry points for all students. So just giving problems with numbers on them, if the numbers are too big, the other students don't have access. But if you're providing the mathematics through the problem solving, then you can adjust the number size, provide a variety of number sets that students can choose. So some students may need to use smaller numbers, but to access and to be able to solve the same problem. You can focus in the classroom on developmental levels or skills through centers or small group instruction. So you can still give them the whole group experience, and I know most of us are required to, but we can, if we know which phase they're in, we can give them specified tasks during some centers or small groups instruction time. So imagine if you were able to reach the individual needs of all your students, and you were able to pinpoint exactly where your students' gaps are in the area of number and operations. So here are some things that are probably true about you. If you're anything like me, you're here with me right now and you're listening to this webinar, and that you know that you have to do something different in order to reach your struggling child, and that this is a good approach and it will help you get to the bottom of the issues around why math is so difficult for him or her. The fastest way to get started is with my book and a simple online tutorial, that I created called Qualitative and Quantitative Developmental Math Assessment and Intervention Protocol. I know it's a mouthful, but I wanted it to say what it really was doing. I created this book because I noticed that I was using the same activities for different students who are functioning at similar stages. So all the kids who are struggling around tens and ones, I noticed, I'm always doing these same activities to move these kids kind of forward. So I wanted something that if I left or whatever, that other teachers could replicate. So I started recording what are all these activities that I'm doing. I recorded, I put in the assessment and a bunch of different worksheets that I had designed for myself, and I put it into this book. And then I made an online tutorial so that other people could see how the questions were asked and watch real children, like me asking real children. So it goes through 10 assessments for elementary age students, with videos on how to assess each one, and like I said, a sample assessment with real children. Not all assessments, the 10 assessments, are given to all students. Some are given to all students, some are given only to the students who do not have a sense of tens and ones, and then others are given to the students who have developed a sense of tens and ones. So kind of the primary and the upper grade students. This provides fillable worksheets for the individual student and for whole class data collection. And the book also has intervention strategies and activities that can be used to address each of these areas assessed, like I mentioned. So in the future, my hope and plan is to have a bank of videos to show how to do each activity, but I just have not had the opportunity to do that yet. But I think that the book itself is quite explanatory, and the book and tutorial themselves are in digital form. However, if a hard copy of the book is desired, then that actually can be purchased on Amazon. If you're a teacher or a parent who cares about your student, and you want to get to the bottom of your students' mathematical struggles once and for all, and you're still wondering how you can assess them to pinpoint them exactly in which phase that they're working, thereby being able to identify their areas and strengths and weaknesses in number and operation, then this program is specifically for you. So this is how we'll do it. The product is accessible in a members-only area on my website. So after registering, I will create an account for you and send you an email to create a password. The program consists of the ebook part has the fillable forms. That's so you can keep track of your individual and class data. You can also print and handwrite on them, which is what I do actually. It gives you directions for all the assessments, so you will know exactly how the assessments were intended to be given, and the intervention strategies for each assessment, so you know different areas on how to address when the student has a deficit in a specific area and how to move them on to the next level. And again, the book is available in a hard copy form at Amazon if that's what you would prefer. Now there's also the video tutorial. It has the videos that explains the worksheets, knows how teaches you how to fill them out, and the options that you have to help you maintain data. Another explanation of the developmental phases, but a little bit more in depth than we did today. Video directions on how to give each of the assessments and a demonstration of giving the assessments to a student so you can hear how the questions are presented. Because you may, especially if you're a parent or even a teacher in a classroom, may be interested in only one age range, the videos are accessible to watch in any order. They're not presented in a module form. So I wanted you to be able to watch the videos of the assessments that in any order, or if you the ones that you wanted to watch and not having to go through all of them. So there's one web page with all of the videos on it, and you can just watch them in whatever order. I would just highly recommend you watch the first ones about the introductory ones first, so you understand about how the worksheets work and the developmental assessments. So this system, again, is what I personally use to assess every elementary age student that I do assess, no matter what age they are. You will receive my bonus ebook, 2-digit addition and subtraction. This was a mathematics unit I wrote when I taught in a second grade classroom, and it has all the lessons for the unit that I designed as the students learned about regrouping with addition and subtraction. There's student work and reflection notes that I wrote after I taught each lesson is in the book. So this book will help you know how you can introduce the concept of addition and subtraction with regrouping and encourage learning of addition and subtraction through problem solving. This is perfect if you have an older child who's kind of still stuck and doesn't really understand what regrouping is all about, and this will help build their understanding of what that is. Yeah, it still gets one better. There's also a second bonus. I really wanted to share with you another book that I wrote, Movement Makes Math Meaningful. It's about lessons from kindergarten through the upper grades, how to get them away from the worksheets, get them out, get them seeing how mathematics is working in their lives, how it's related to their life, for those kinesthetic learners who just don't like to be sitting and just doing math on paper all the time. It's correlated to the Common Core standards, and they are grouped in units by the type of material that's used. You've watched this whole entire presentation, so I really wanted to pay you back for that. You know, you want to help your child improve in mathematics, and you know that this is an excellent value, and you are still here. So please take advantage of this incredible discount and the great bonuses. You have absolutely nothing to lose and everything to gain. So I want you to go and click the link that's below this video and enroll today. And I wish you the best of luck as you are working with your child to improve his mathematics. And please feel free to reach out to me for support or any questions that you might have along the way. I'm here to help empower parents to work with their children. Thank you.